Hello folks. In my $0 way of doing things here, I've tried to create a model of what it looks like inside a drill press's spindle. What we've got to explain basically how a worn out feed mechanism can cause catastrophic drill failure. Now what we've got here is a workpiece down here. It's a plate of steel, let's assume. We've got our drill bit in here, with the taper shank and all that. We've got the quill, that's this part here that slides up and down. And we've got the gear train here that actually drives it down inside the machine. This here is run by the motor. Whoops, there we go. This is run by the motor, and you can run it either with power feed, or on most drill presses you can also operate it by hand and bring the tool into the material here. So what we've got is basically the drill here right on the surface of the material here, just because I'm kind of running out of vertical space in my illustration. And we're going to feed this through, and I'm going to show you what happens and how a loose feed mechanism can actually cause your drill bit or what have you to fail in actually a very dangerous way. Okay, so what we've got here is, we loosen this up a little bit. Whether it's done by the machine's own power, by setting the feed rate, or whether we do it by hand, what you do is this wheel here, this pinion, actually pushes the rack down, which is machined right into the quill here. So the quill goes down, pushing the drill into the material that you see right here. Okay, all fine and good. Now as it goes through the steel there, depending on the condition of your drill and your setup and such, the drill is supposed to cut the material, but a lot of times it doesn't quite cut it. It actually just pushes the material out of the way. Now generally up here in the thick part, it'll do all right, but once it begins to break through, right here is where it begins to break through. I'm going to see if I can get the cap off this pen here first. Boink, there it goes. It's going to push the material out like this. Metal does not want to get cut. It resists, and it uses its plasticity to bend and flex and mush and move out of the way rather than cut. So if your drill isn't as sharp as it should be, then that's going to present its own problems. Let me get that cap here so my pen doesn't dry out. That's going to present its own problems. As it pushes through, if that drill's in good shape, it'll break through right there and it'll cut that chip out of there. Okay, so it progresses through like that. But here's the thing: when the drill is pushing through there, you're forcing it through. So your contact is on top of the spurs on the rack here. But when it bites through down there, what's going to happen? Because you've got this big gap here because of wear in your between your pinion gear and your rack, it's going to jump down like that. And when it does that, here's where the machine or your hand is pushing it through. When it begins to break through, all of a sudden it's going to go dunk like that, and it's going to bite through all of a sudden. Now what that means is that whatever this gap is, that's how big a bite your drill is going to take all of a sudden. In the course of one revolution, it might be taking, you might have it set at something like an 8 thou feed rate. As machinists, we understand that. We know that's, yay so much and all that, and it's like, hey, that should be no problem. But now all of a sudden it's taking up that gap there, and that gap could be 10 thousandths, it could be 30 thousandths, who knows what it is. But when that happens, all of a sudden these teeth here, the two cutting edges on your drill, are taking out a bite much more significant than what it normally would. And all of a sudden that big bite right from here where it's being pushed in to right there where it jumps through and breaks through the bottom side of the material, pow, there goes your cutting edge, just like that. And it'll break off. It will sometimes break off the entire point, but usually just chip real badly both cutting edges there. My fancy little props here don't work so good. But there's something else I want to point out here. If your drills aren't resharpened well, if they're not cutting as good as they should, as I said earlier, they're going to push that material out. And occasionally we'll get chips like this right here. I want to show this to you. This is an interesting one in my book, because I love looking at chips. You look at that, it looks like one of those little hats that Asian people wear when they work out in the fields and such, just a little cone. You can see where the drill, this is the bottom surface of the material here. This came out right down there at the bottom of the material. and the drill's up on top here, and it pushed through. And as it pushed through, you can see that, whoops, let's get it up there so you can see it. You can see that it actually broke through there in a few places, right in the point and a little bit outside of that. It did actually break through, but it didn't really cut the material. It's just pushing it and pushing it and pushing it. And all of a sudden it does break through and it punches out this chip. I don't want to talk about this chip for just a little bit more, but when it does that, that's going to cause your drill bit to break, because all of a sudden it's taking that huge bite. This has to be taken care of. The machinist can't do anything about that. Now, if he's feeding it by hand, he's got a chance of feeling it when it's breaking through and easing up, so that that isn't quite so such a big bite or quite so dangerous. He can control that. But on power feed, like a lot of guys like to use, you've got no control over that, and it's just going to bang right on through there, and there goes your edge 9 times out of 10. Back to the chip here for just a minute. This is interesting because it's not ordinary steel here. This is a stainless steel chip, this one here. And that's why it's got these peculiar colors. I don't know how good the camera's going to catch this, but it's supposed to be a slightly goldish silver color. But this here is a lot more gold and brownish than what it should look like. And that indicates it's generating heat. Okay, we know that. Metal cutting gets hot. But here's the other thing. You look at the center of this, and ordinarily, it'd be the outside edge of this that would show the greatest concentration of heat, because that's where your surface feet per minute are the highest, and that should show the most amount of heat buildup. But it isn't. It's the center. And it's the center because that's where it's rubbing. It's not cutting at all. The outside edges are sharp enough. They're trying to do their thing. But the chisel point on the drill is having a tough time breaking through, and in fact, it just barely does. And so consequently, you get that kind of a rose color inside there. But there's one other thing. Do you notice that ring down in there? Looks like it's about a 1/2 inch or so in diameter. That is very significant, because you look at that and that tells you that that drill is already compromised. It's got a chip in probably both cutting edges there that is so severe that it's leaving a huge ridge down there in the bottom of that chip. And that means it is not cutting. It is just rubbing and waiting for something bad to happen. You know, you've got to make sure that your drills are in good shape, and that may have happened when it entered the hole. It might have happened from the previous part that it ran. Who knows? But before you put a drill in, inspect those cutting edges. Make sure they're sharp. Make sure they're in good condition. But then also for this right here, this is something that generally speaking the machinist cannot remedy. He cannot fix this. It's simply worn out. And once again, it gets into that issue of throwing good money after bad. If your spindle is worn out, you think, oh, all we got to do is regrind the spindle and we'll be good to go. No, not necessarily. It could be your feed mechanism that is also bad. Now, if your feed mechanism is bad, there's a good chance that the slideways are also wasted, that the entire power transmission for setting your RPMs is also toast. A lot of things deteriorate altogether. And you've got to be careful. You can fix one thing without solving your problems, because you've got other problems further up the line here. So anyhow, I hope that answers a couple questions about pushing your drills through metal. Sometimes it's your operator's fault. Sometimes it's the tool's fault. Sometimes it's the machine's fault. And by fault, I just mean responsibility, or that's the cause, you know, ultimately where it comes from. Alrighty, thank you very much. I hope you folks have a good day. God bless. Take care.